Okay. Okay, today, this is part 10, Master Carpenter Series with Lewis Thomas. And what we're going to discuss today is we're going to figure the jacks. We're going to figure the jacks for this roof. And I think another thing I'm going to do before I even get started, I want to give you a bird's eye view into this little chart here that I have, this diagram that I have, because I want you to understand the perspective of how this is drawn. So, and how it's how I'm looking at this and why I have drawn it this way. Okay, the best way I can do it, just show you. Let me just show you. Let me just show you this. All right, now, when you look at, I'm going to draw this triangle here from another perspective, okay? From several different perspectives, so you can get the concept very clear. Now, okay. Now this right here is, in fact, the same as this. The only thing is you can't see this line because it's perfectly in line with this front line. So this hip is blocking for you from seeing this. And this line right here, which is the king common for the 12-12 side, is actually this line. You see that? What I do is I twist it to the side so you not just see this line and the bottom line, but I draw it so you can see this line, and a third line. Okay? And I'm just going to draw this, or draw this way, so you can get an idea of what I'm talking about. Now, because I have drawn this way, now you can see this side. So this right here is the 7-12. That's the 12-12. Now, the reason why the 12-12 look like it's going straight up is because you're looking at it one-dimensionally and you're looking at the paper right on. Just like if this calculator just like this triangle right here. You're looking at it right on, okay? So this one here, you can't tell if it's a slope to it because you're looking at it dead on, you see? But if this is a roof, and if you look at a roof out from the street, you could tell that it has a slant because it's three-dimensional, you see? So this right here would be the king common, and for the 12-12 side, represented by this. This would be the king common for the 7-12 side, represented by this. And this right here is the hip, represented by this. So you see that, right? So I draw it this way so you can get some perspective on the depth of the reason why I draw this one this way. And I'm going to do this here, because I know these graphs could be a little confusing. The reason why I draw this thing this way, well, I don't need to draw it again. I got it right here. The reason why I draw this thing this way is so you can see the depth here. So you can see the run for the 12-12 side. And you can see the run for the 7-12 side. And then you can see the run for the hip. That's why I draw this like this. And I have enough room to write all my measures. You see, that's why I write this like this. That's why I draw this like this instead of like this. And this line right here is an imaginary line where all three of these are united. All right. So I hope that helps you out and gives you some idea of how I deal what this is. And look at this. I want to show you this too. Now, I only draw half. You can see this is half, okay? And I'm going to do this right here, just so you can get an idea of what I'm talking about. I don't draw the other half of the triangle because it's not necessary, because the rafters on this side of this line, the king common, it's going to be exactly the same thing as this side. So I don't need to figure out for that, okay? All I need to do is reverse, you know, when I'm doing my hips and stuff, I reverse my bevel, you see? So this right here is an A-frame roof. This front is sloped back, but you can't tell because you're looking straight at it, and I'm only drawing this in 2-dimensional on a piece of paper. I give it a little depth by adding this so you can see the king common for the 7/12 side. All right, this is the hip, which is 8.55, and this is the 12/12 king common rafter. All right, so I don't draw this part right here that I'm putting the squiggy line through. I don't draw that part, okay? And I already told you why, because everything on this side is going to be a duplicate of what's on that side, ideally. All right, let me see what else can I give you all. I want to give y'all some good information today. Now what we're going to do is deal with jack measurements. All right, we're going to deal with jack measurements in part 10. What else are we going to deal with? And the plywood measurement. So we're going to deal with jacks and plywood angle cuts on the sheets. All right, that's what we're going to deal with. So without further ado, let's get started. So we already know this is how you get your jack measurements for the 7/12 side, which is this side, 7/12. This is how you get it. Should be able to see my calculator good. Okay, we're going to clear out everything. And clear out the whole calculator. Now what we're going to do is we're going to take the feet. We're going to work with the feet measurements, okay? So we got 2.242. All right, we're going to take that and divide it by the run layout, which is 16 on center. All right, and we're going to multiply it by, no, we're going to take this number and divide it by this number, which is the run per run layout, basically. Right, so what we do is divide it by 1.130 equals 0.984. So what we do is write that down. Now this right here is your step off per square inch. I mean step off per inch. So we probably write 1. Make sure my paper is straight. We write 1.984. Okay, and we write this S, step off, SO per inch. Okay, SOPI is what I say. It's your SOPI. So we know that for every inch, for every 1.984 inches of run, well, I don't know how to say it right now, but next thing we're going to do is figure out what it is for our first rafter if we pull in 16 on center, okay, and that's 15.25. Okay, so what we do is we take this number and multiply it times 15.25, which is 15.25 equals 30.25. So we write because your first rafters ideally is going to be 15 1/4. Okay, so this, we're going to write this as the first. Excuse my writing. This is first, I'm telling you. So if you can't read that, so that's the SOPI, which is, or step off per inch, 1.98. And you want to see what this is going to be for a rafter that is spaced 15 1/4 inches away from the king common, right? And so it's going to be 30.25. Now what you want to do is go back to the SOPI, put your SOPI back in the calculator, 1.984, and now you want to see what it's going to be 16 on center. Okay, your deduction, or your deduction for 16 on, for each rafter, 16 on center or addition. It depends on if you start from the lowest point, measure from the hip, 16 on inches, 16 inches on center. Okay, you're going to be adding. So let me get this first. So we got 1.984 times 16 equals. So for every 16 on center, the deduction or addition, depending on where you're measuring from, if you're measuring from the hip back towards the king common, you're going to be adding 31.74. But if you're coming this way, the from the king common to the hip, the raft is going to be getting smaller. Okay, and it's going to still be, but it's still going to be 31.74. So we're going to put 31.744. We'll just go 3 places, and of course these are inches. All right, so now we know we really can figure out all of the jacks. And I'm going to also show you where you start measuring on the jacks. I want to show you where you start measuring on the king common, where you hold your tape measure on the king common in order to get your first jack measurement, and then your 16 on center. So for this one, we're going to put 16 on center. Okay, now for the others, now what we're going to do, well, we might as well do the plywood here. The way you do the plywood is real simple. You take the same measurements, this measurement and this measurement, but this time you don't divide this measurement by this measurement. You divide this measurement by this measurement. Hey, how you doing? Pretty good. So you divide this measurement by this measurement, and that's going to give you your tangent. So we got 1.130 divided by 2.242 equals. Okay, so what I'm going to do here is 0.504 0.504. Okay, and now 0.504 is an important number. We're going to take that. We know that a sheet of plywood is 48 inches. So we take this number, 5.504 times 48 inches equals. So this means that we're going to do this. This is 48 inches, all right? .48 inches. And then we know that this right here is 24, not 21, 24.192. Okay, 24. Now what we do, we're going to put this here. We're going to circle this so you know these are not one number. So we got 42.129 and we got 48. What we do is the Pythagorean theorem now. So we square this number. Squared plus 48 squared equals, and then square root. And now we know that the angle on the plywood is 53. The length of the angle is 53.75. Okay, so we know that this angle is 53. The hypotenuse, 53.75 inches. Okay, and that basically right there is your cuts for your sheet. So on every sheet, you can either measure the 24.17, which is 24 1/8, or you can measure on an angle. Put a nail on your sheet and just measure 53. Pull your measurement, whatever your measurement is, and then from your measurement, pull 53.75, and that's going to give you your angle, your exact angle. Okay, so we just figured out how to do the jacks, how to do the step off for the jacks, which is 31.74. Get the first jack, and then the reason why this SOPI is so important is because if you have a skylight or you have some joists, a skylight, and you got to put a joist in a strange place for a dormer or whatever, you know, usually you don't need to use the SOPI. People would just tape that off. They'll just measure that, you know, it'll be way faster just to measure it and all that kind of stuff. So yeah, but the SOPI is good for cutting your jack measurements if there's no protrusion in between any of the jacks, like a dormer, a skylight, or anything like that. Okay, if there's a skylight or a dormer and something like that, you just want to tape that off, you know, and have a tail pattern where you just have a guy cut that. You don't want to be, fooling around. You're in this business to make money, and you want to go as fast as you can. But this is nice. This is nice to know. So we figured out the 712 side. We noticed the plywood cut. We know the SOPI. We know what the first jack is going to be coming off the King Common. And if you don't want to do that with the first jack, and you just want to lay out your plate and then measure from your hip to your first measurement and then add 31.74, you can do that way too. You see, especially if you got a big roof and you got a whole lot of different jacks, a lot of jacks that are the same. That's what you want to do, and you want to have a pattern and all that kind of stuff, and like a mark off board, with a step off board with all the marks for your rafters and everything. So now we're going to do the other side. The other side is exactly the same way, y'all. You have the point. This is the foot, 0.812. Okay. So what we're going to do is figure out the jacks SOPI first, which is the step off per inch. So 0.812. 0.812 divided by 0.984 equals. Okay, so we know that this one is I want to do this. Okay, we're going to do this. And we're going to write this 0.825, 0.825. We're going to write that inside the triangle instead of like I did over here outside. I should have wrote this on the inside. We notice this is going to be 48 inches because that's how long the sheet is. Okay. 48 inches. And now we're going to multiply this number by 48 times 48 equals. So we know that it's going to be 39.609. Okay. Basically 39 5/8 inches. Now what we do is work the Pythagorean theorem. Oh, wait a minute. I'm doing this wrong. I'm doing the sheet. I'm supposed to be doing the step off. This right here is the step off. This is a SOPI. So let me cross that out. I got ahead of myself. This is the SOPI. 0.825 is your SOPI. Step off per inch. Step off per inch. Okay? We take that number, 0.825, and we multiply it by 15.25 equals. Okay. It is, so the first rafter is going to be the difference from the king common is going to be 12.58 inches. Okay. Okay. Now what we're going to do is get the SOPI and put it back in the computer. 0.825, and we want to multiply it by 16 to see what it is. 16 on center, and we're going to put first here because the first rafter is 15.25 inches. Okay, we're going to put ST. That's for the first rafter. Then this one right here is 8.25 times 16 equals 13.20. All right, and that one is 16 on center. Now I know this paper is kind of crowded here, but when you go through the tape and everything that I'm going through, you'll be able to see exactly what I'm going through. You can't get to part 10 and then just look at this and say, man, what is this garbage? All of this was an evolution and development of various ideas that are put on one sheet of paper. Now, when I'm normally doing my doing this for a job, my paper is not this crowded or messy. It's a lot neater. Matter of fact, I want to show you how neat it is. This is how neat it is. You see that? That's how neat it is. That's exactly how neat it is. Very, very neat. Very, very legible. You see? And I usually do this on a block of wood. And it's this neat. I'm doing it this way. It's this sloppy here because, you know, because I'm trying to explain everything. I've never tried to explain this, every little detail, and give you clues and put myself in the mindset of a person who is a novice, first learning this, all the way to a master carpenter. So it's a lot more going on here than meets the eye than I would normally be doing if I was figuring this out on a job site or for any type of job. So we got 16 on center. Our difference